Today I'm going to show you how to put the sprocket together for the fabric kit that you recently purchased. You see behind us we've got the fabric assembly all set up. That's what you're going to be building. So right now we're going to focus on assembling the first part of it is the sprocket. Set this out of the way after you get a look at it. So what you're going to do first off is in your kit, you're going to dig out the parts and pieces for the sprocket. So you're going to see these rings. You're going to need 2 for each sprocket. They're identical, so it doesn't matter what the orientation is of them. And then you're going to see sprocket face. Sprocket face is almost universal. However, when you look at it, you're going to see a tapered seat in 2 of the holes. That will determine its orientation when we put it together in the fixture. But for now, we're just going to ignore that, and I'll touch on that when we're putting it together. Aside from that, you're going to have your pins in the kit, right? And you're going to have your assembly bushings. So that's basically what you're gonna need to put the sprocket together. Now, one thing I will say is in order to keep the price manageable as possible, we don't spend a whole lot of time getting these cosmetically perfect. We prepare them in terms of getting the holes round and true and in the right place and making sure that everything fits. But beyond that, as far as sharp edges, burrs and whatnot, we don't spend a whole lot of time on that, because the whole principle behind this kit is to give you, the customer, the most affordable system you can possibly get your hands on. And if we do everything at our end, that just brings the price up and defeats the purpose. So this is a sprocket that came right out of the tumbler. It's a bit wet right now, but I'll see if I can show you what I'm talking about. So if you look around the edges and whatnot, you're gonna see where the, just from beating around in the tumbler, left some burrs and stuff. So what you'll wanna do is take your grinder with a flap disc and smooth that off. And don't just stop at smoothing it off. Another thing you're gonna wanna do, and we did it already on these, you might be able to see there, any sharp edges that you can get out with a grinder, just try and round them off a little bit, because what'll happen when you go to paint this or powder coat it or whatever type of protective coating you put on it, if that's a sharp edge, which it will be when it comes to you, the paint or powder coat or whatever will want to wick away from that sharp edge. So that's the first part where your paint will fail, is on all those sharp edges. So a little bit extra time prepping these before you weld it will save you a lot of misery down the road. So so beyond that, I've already got these parts prepped. So I'll set this out of the way. This is just for demonstration. The next thing you're going to want to do, and this is our secret, weld splatter, right? So there's a million different brands of anti-splatter spray on the market, and we've tried them all and had 0 success. Just miserable experiences with all of them, and for the longest time we didn't use anything. We just chipped off the splatter and dealt with it until I discovered spray-on canola oil. This is the same stuff you cook your pancakes and eggs with. Beautiful stuff. So what we do is we wet everything, but we don't want to saturate. We don't want to soak it. We just basically want to take the steel from looking dry to looking wet. So we'll give it a little dusting of canola, not a whole lot, because we don't want it to puddle down where we can't wipe it off. But then we'll take our rag and we'll wipe it off thoroughly. so that it doesn't interfere with our weld. So long as this is just kind of a wet finish, it won't affect your weld. If it's saturated, then you're going to have porosity and your weld is not going to be what it should be. But the benefit of doing this is if you don't prep the part for splatter before you weld it, you're gonna spend some more time on there chipping that splatter off. What happens with the canola oil we found is when all those little droplets of weld, of molten metal, land on the part, typically they would bind instantly because it's hot metal. Metal sticks to metal. With the light coating of oil, it has, I believe it's called the lead and frost effect, where that puddle or that droplet of weld, instead of just sitting there and soaking in and binding, it'll just skip off. Like it just bounces off. There will be the odd one that will stay, but probably I'm going to say 90% of the splatter is going to just bounce right off. And what does stick around, most often you can just pick off with your fingernail. So that's our trick. Use it if you want. Don't if you don't. It's entirely up to you. So we've got all the parts here. I've already oiled just about everything. The pins also is a good idea because they're kind of a bugger to get at after to get the splatter off. So we'll give them just a little dusting. I left 3 of them out just to demonstrate. Just give them a squirt and then pull the oil off. Make sure that no oil, and it doesn't hurt if you've got yourself a fancy welding table and you want to keep it good. Like a lot of this stuff I'm telling you now, like I don't know, you might be a Red Seal, the top dog of welding, or you might be just a guy in your garage. This is one of your first projects that you're going to use to teach you how to weld. So please don't be offended if I go into a little bit too much detail with crap you already know. I'm just trying to make it as broad as possible so that we can, address everybody's potential questions. So we've got this fixture table here that we build. If you want a fixture table, we can hook you up. Just shoot me a message. But you don't need a fixture table to put this together. I just needed a table, so we built one. But if you want to keep it good, give it a little spray of canola oil as well and wipe it off. And the same thing, all those little droplets of weld are just gonna dance off the surface of the table, and your table's gonna last a lot longer. You're not gonna have to go and grind at it. As soon as you grind this surface, then the weld sticks even better. So you wanna, keep it as smooth and flat as possible for as long as possible. So we're gonna start putting this sprocket together. We'll set the center ring out of the way for a moment. And I'll grab one of these outer or inner rings, whichever orientation you put it in, it doesn't matter. And then we'll take our bolts with bushings and take that all apart. Pull the bushings. Oh, that's noisy. Take the bushings off. Have to apologize, the sound quality is just going to be fair today. With all that's going on in the world right now, we had to do a low budget approach to making a video. Generally we hire a professional to do it with us, and quality is generally a little better, but in order to keep things rolling and get everybody going, this is what you get today. So we start by putting our bolts up through from the bottom. We're going to go through these pinholes right here. What we want to do is distribute them. We got 4 of them. We want to spread them around evenly. So use your eye. It doesn't have to be perfect. It's generally like 5 holes in a bolt, 4 holes in a bolt, 5 holes in a bolt, and 4 holes in a bolt, because there's 22 holes. So we're gonna start by putting a couple in here. We're gonna 1, 2, 3, 4. We're gonna go there. Right. spin it around. 1, 2, 3, 4, 5. I'm gonna put it here. 1, 2, 3, 4. Put it there. All right, so we got our bottom ring set up with our 4 bolts sticking up. Next thing we want to do is pick up our bushings, and we want the short bushing, okay? Not the long one. We're going to start with the short one. And we're just going to drop this bushing right over the bolts. 1, 2, 3. Where's our 4th bushing? 4. Okay, now we got our 4 bushings on. That's going to set the distance between this ring and the sprocket face. And now this is where those chamfered holes that I was talking about right here come into play. So these chamfered holes have to face down toward the small bushing. If you put it on the other way, you're going to go and put this on the vehicle after, or on the track system when you go to bolt it up to the hub, and you're going to find out that your screws don't countersink because the countersink is only on one side. So you want, like I said, the countersink, the chamfer, to face down to the thinner side, to the short bushing. So, and then beyond that, doesn't matter. Wherever they line up, drop them on. So there, now you've got your inside ring, your sprocket face, and now we're going to put on the outer ring. So we'll grab these 4 long bushings. 2, 3, 4. And then we're going to grab our outer ring. And we're going to drop it on. Again, it doesn't matter. It's symmetrical, so just drop it on where it looks good. And then you can start putting the nuts on to hold everything together. So I've been doing this for quite a few years. I've seen 100 different ways of doing this. Everything from, you know, just hacking it together, everything to this big complex fixture. And we've tried a variety of different ways. And over the years, it's proven that this is just the best balance of simplicity and accuracy. These bushings are all machined perfectly to length, all identical, so it keeps everything straight, true, and then because the bolts go down through the pinholes, that keeps everything in perfect alignment. So when you get 4 of them in there, and then you tighten these nuts down, all of your pinholes are going to be in perfect alignment, which means your pins are going to be square and straight. All your faces are going to be the appropriate distance apart, and then all you got to do really is just drop pins in, weld them in, and really don't have to worry about it a whole lot after that. So what you want to do is get these nuts all kind of finger tight. You don't want to go and tighten one up before you got the others snugged up. So we'll get the 4 in here, and then we're just going to go around with our wrench and give them a little bit. Now, you don't want to go crazy on it. There's no need to go crazy. Just a little bit snug, and Bob's your uncle. So that's essentially, that's your fixture, right? So our kit, throughout the whole system that you're going to watch us put together, our parts work in conjunction with some of our tooling that we supply with the kit to be its own fixture, so that you don't have to purchase these big complex fixtures which are going to cost hundreds of thousands of dollars, and you don't need a specialized table in order to do it. We take advantage of hole placements and whatnot and use that to make our assembly of the kit as simple as possible and as accurate as possible, so that we can keep the price as low as possible without sacrificing the end quality of the track system. Because we want you to have the best set of tracks you can have. We want everybody to know you have a good set of tracks, so we don't want them to fail. So we do our best to give you the best shot at building the best set of tracks you can. And this is one of the ways we do it. So the next step is going to be putting the pins in. And what you're going to notice is the pins are about, I'm going to say, 1/8 of an inch or so shorter than the distance from face to face, from the outer faces. And we do that for a reason. Now, if we were to take this, right, try this again. If we were to take this pin and, you know, if it was flush, and you tried to weld around that pin right there, in order to get enough penetration, in order for that to be secure and solid, you're going to have a big mountain of weld there, and we really don't want that. So what we want to do is drop this down and take up that difference. We want to split the difference from this side to that side. So we'll drop it down about half the thickness of the plate, maybe not quite half. And then we're going to put a tack weld on there, and that's going to hold it into place. And then we're going to do that to all the pins all the way around. And then we're going to flip it over, tack them in again, and then I'll show you the next steps on that. So I'm going to put my lid on and start tacking away. Hopefully everything turns out in the video as clearly as I'm trying to explain it. We'll probably fast forward through a couple of these sections because you probably don't really want to watch me weld for 10 minutes here and 15 minutes there. But anyway, start grabbing pins and dropping them in. Now, when you're putting these pins in, you're going to want to hold on to them. And another thing you're going to want to do, you're going to find that the hole that the pin goes in is slightly oversized. So what you want to do is don't let it come to the outside edge. Push it in towards the center as you tack it. And that'll make sure that it doesn't stick out, you know, when it's all done, and you know, take it around, I guess. I don't know if you can see that in this camera, but all we have is tacks here for now. What we want to do is put as many tacks on this entire sprocket as we can. If you're impatient like me, you might be inclined to, you know, start welding, right? And then assume that everything's going to work out. But what'll happen is if you start welding, weld has a tendency to shrink when it cools. And that's basically your ultimate enemy when you're building something that's supposed to stay square, stay round, stay true. You don't want it to pull. So what you want to do in order to resist that is to basically, we're going to put our tacks everywhere we can to lock it as much in its position as possible. And then in the beginning, we're going to spread our welds out and spread our heat out so that, you know, we'll put a button here, maybe a button over here, and a button over here, and a button over here, so that, you know, when we weld this one, if it did pull a little bit, when we come over here and weld this one, the pull from this side will somewhat counteract the pull from that side, and it'll all balance out in the end. So as much as possible, you want to jump around with your weld. Don't want to concentrate heat in one area or weld in one area because it'll cause you problems down the road. So you don't get any extra parts in the kit. So you want to make sure that the parts that we gave you come out the other side the way they're supposed to. So that's just one tip. So now you're gonna notice you got 4 pins left. That's okay. You got 4 bolts here. Once you're all done welding this, we're gonna weld it as much as absolutely possible. And then we're gonna pull these bolts and bushings out. These 4 pins will drop in their locations, and that will be the last bit of welding on this sprocket. So right now we've got one side tacked. We're gonna flip it over and do the same to the other side. And then we're gonna come around the perimeter and put some tacks on there as well to just help lock it into place. So we'll flip this over. Another tip that you're gonna want to do is these pins, again, because the hole is oversized so that there's no clearance issues with the pin, they're likely to want to be closer to the outside than the inside. But when you start to put your tacks on, what you want to do is just press them in or pull them in from the inside, and that will help you to keep everything in and tight and where it needs to be. So you'll see that in this step. So there we have one side fully tacked. Good idea to keep your nozzle clean. A little dose of oil works there too. And then finally we'll do the tacks around the edges here. So. Okay, so now we're all tacked, and the reason we did our tacks on the outside is simply because this weld that we do around here is going to be fairly visible, and we personally want our welds to look as good as we can make them look. And if we put a tack on the inside, it'll still work fine, but the issue will be that when we go to run our puddle around there, it's going to have to climb over and melt that tack, which is going to leave a lump in our finish weld. So it's easier just to put the tack out here, and then it doesn't interfere with the weld. So I'll grab this camera here, and so you can kind of see what we did here. I didn't maybe sink them quite evenly, but they're good enough. All right, so that's that. So now what we want to do is we're going to start putting our beads around the pins here. And again, we're going to, because these are hot beads, right? I guess we don't want it to pull. So I'm going to put a bead around here and a bead around here and a bead around here and a bead around here. And then I'm going to flip it over and do that again. That'll help lock it a little bit more securely. And then we'll start doing all our beads all around the pins on both sides before we come to the outside. And the reason we do that for no other reason at all is if we go and weld all these buttons right now, that's going to be screaming hot. We're going to be reaching in here and burning our arms, right? So we'll focus on those first, and this will be the end of it. And there's probably half a dozen different ways of doing this. You might want to, you know, tip the sprocket up like that. Whatever, it's entirely up to you, whatever feels most comfortable for you. I like to do it flat. I can weld with both hands, so I'll do a half and a half and then end up with a fairly nice weld. But it's however you want to do it. So. I'll grab the camera again and give you a closer look. You can see what we did there. We welded it around. We don't worry too much about where the weld comes to the outside. You can finish that off later if you want. Not necessary to weld any more than that on a pin. So as I said, we're going to flip it over and do the same thing on the other side. And then once I do have it flipped over, I'm gonna do the 4 pins, and then I'm just gonna keep on trucking. I'm gonna do all the pins on that side. I'm gonna flip back to this side, do all the pins, and then we can move to the outer buttons. Another preference of mine, I don't know how you're going to be welding these. If you're going to be using a MIG, a stick, or a TIG, I recommend a MIG. It's the fastest, easiest to learn, easiest to use. The results are more than adequate for what we're building here. But I like to use 035 wire. When you're welding thick plate, you have a tendency to go to 045 or something thicker. But I like to stay on the thinner side with the wire because that allows me to to control my puddle just a little bit more. It gives me a little bit more time. I'll crank the heat as high as I can go, put the wire speed just enough to catch up with it, because we want our weld not to be a mound, we want it to soak in and flatten out. So I found with myself, I hit the best results with 035 wire. But use whatever you want. There we go. All right, now that we got these all welded around on both sides of the pin, pretty safe to say that none of this is going anywhere from this point on. So now, because it's facing this way for no other reason, I'm going to finish my buttons. And another thing about these buttons is, what you want to do is, I don't know if this camera can see it, but start at a corner and work your way around to the other corner And then you might be inclined to try and skip back over to that corner and keep going around. But what might happen is, because that's a hot molten puddle at that point, it might want to fall out that gap. So what we tend to do is start at a corner, work our way around till we're almost at the last corner, and then we'll zip into the middle, and then we'll just start doing circles and make a hot pool, and that'll kind of wick its way out to the outer edge, and we stop before, you know, before it falls off. It's not the end of the world if it does fall off. You can touch it up, but that's just what we do. So. You can kind of get a peek of what the button looks like after we're done. You know. We want those buttons to be as flat as possible. You don't want big humps there, they just look ugly. So we'll keep going. So there we have it. We got one side fully welded pretty much. We've got a minimal splatter. I'll show you that in a bit. So now the next thing to do is just flip it over and repeat the process. We're going to start on the pins on the inside again because this is going to get hot and we don't want to burn ourselves, right? So that's going to be how we do it. All right, so there we have 90% of it done. The next step is to take these bolts out, drop the last 4 pins in, and weld that all up, and then do a bit of cleanup, and your sprocket is done. You can move on to the next one. We'll flip this over. I like to cheat, right? Warm. Grab my mitts. Line that a little bit. Stand it up and pull the bolts out. And our bushing should, for the most part, fall out, but there might be the odd one that's a little sticky, just because the metal tends to shrink as it cools and gets a little tight on everything. All right. So we're going to set these a little bit out of the way because we don't want to get any splatter on our parts. Just make it harder to put them together. for the next one. Grab our last 4 pins, and same thing, we'll drop them through the hole, try and split the difference, and tack them in. Oh, come on. And we'll flip it over and do the same on the other side. Jesus, I'm having a hard time. I'm going to go in and weld them to the sprocket face before I come out and finish off the buttons. So that completes one side. Flip it over, do the same. So that pretty much completes the welding portion of building your sprocket. Next, you're going to focus on cleanup. So if you're you know, professional welder or experienced welder, you know if your welds are going to hold or not. If you're a novice welder, this is a project that you picked up to kind of help you learn, and you're not sure, you think they might hold, you think maybe, maybe not. You can put more weld on. You can finish these out. You can weld, you know, the back side. Like you can weld all the back of those pins if you want. You can close out all of those joints if you want. Right there, right there. Finish off the outsides of the pins. You can put extra weld on, but it's absolutely not necessary. It's, you know, we designed the system to be fully, you know, structurally sound with this much weld on, provided the weld is done properly. But again, like I said, if you're not 100% sure that your welds are going to hold, you want a little bit more insurance, by all means put a little bit more on the backside. The next thing we're going to do is do a bit of cleanup. Okay, so put the welding lid away. Put our safety glasses on. Clean them, of course, with a dirty t-shirt. And what we're going to do is we're going to try and leave the buttons alone. Like, we don't want to take these buttons and sand that all smooth, because those buttons are our structure. That's the meat that holds the pin in the ring. So we want to leave as much meat there, as much glue there as possible. But we are going to just lightly go over them with the flap disc, just to get any raised edges, any sharp edges, any corners, and smooth them out, flatten them out, so when it comes time to paint them, it looks a little better. And then we're going to go around the outside as well, and you'll see some places where the weld spilled over, right? So we're going to knock that off. Basically true the outside, make sure that there's nothing sticking out any further than the profile of the ring. And then we'll go over our edges one more time to make sure they're just a little bit rounded. And then chip our splatter off, which is minimal. I'll show you that. Well, there's an example of a dingle ball right there. And it just rubs off, right? So that's the benefit of the canola oil. It all just picks right off. For the most part. Maybe the odd one that'll stick, but that's minor, right? So grab our grinder with our flap disc, and got to plug it in. Here's I didn't keep my cord with me. Now we're just going to go over this. Look for anything sharp and take it off. We just run our hand around that with a glove on, of course, and make sure that there's nothing that's going to catch the finger of our glove. And if we get around it and we don't feel anything, then we're ready to go on to the other side. He's noisy. And do the same thing on this ring. Same thing on this side, run your hand around it. Feel anything sharp or sticking out, take it out. And then grab yourself a cold chisel and start looking for slag to chip off. Not slag, splatter. It's inevitable that you are going to get some stick. Most often it'll be really close to the weld because that's the hottest area on the sprocket. But in general, you know, that if you didn't do that, this whole thing would be covered with little beads of weld that you have to clean off. So that just takes more time, creates more misery. And just like that, your sprocket is ready for sandblasting or painting or powder coating, whatever you intend to do to finish them off. That's entirely up to you. We did our best here to show you what we feel is the best way to put this together. Keep in mind, we only send enough parts to build one of these, you know, one system. We don't send extra parts in case you screw up. So if things go wonky because you went out of order or whatnot, then you're gonna have to order more parts. That's just the way it's gonna be. So that's everything. I'll get you a little zoom in here. So you can see how we welded all the way around those pins and our buttons in the top. When we come around the edge, you can see we kind of rounded that edge a little bit. And we made sure that anything that was sticking out got smoothed off. And again, these pieces here, you can finish welding that if you want. It's not necessary. There's more than enough weld to hold that pin in there. But if you're not entirely sure of the quality of your welds, or maybe you got a little bit smaller welder than, you know, ideally you should have, then a little bit more weld isn't going to hurt anything. So that pretty much sums it up for the sprocket. Next, we're going to work on the tower. We're going to show you how to weld the spindle into the bushing. It's already pressed into the bushing. We're going to teach you how to do that, how to put it onto the tower tubing to make sure it's square, straight, and true. And then after that, we're going to move into rails. So this video is going to end here. There's going to be a series of videos for every step. If you have any questions at any point in the process, by all means, reach out. Give me a call, give me a text, shoot me an iMessage, message me on Facebook, whatever. I don't mind answering questions. I'd rather answer a question than see you disappointed with the product. Just only thing I ask is consider time of day. We're on the East Coast. If I'm in bed, obviously, I don't want to get up. So there you have it. So step 2, tower and bushings, next video. The links will be either in your email. We're going to do our best to put them maybe here or somewhere in the video that you're watching right now on YouTube. See you in the next one.